Hello friends, I am Herbert and I am going to take your high voltage engineering class where we are broadly focusing on the various types of insulating materials in the form of the different states. So like the gaseous insulations, liquid dielectrics, solid dielectrics and the composite dielectrics. Okay, so today our point of agenda to discuss is completely on the liquid dielectrics. Okay, so here I have given the title that the breakdown mechanism in liquid dielectrics. So there are number of processes which we can see with liquid dielectrics to observe the formation of the spark when two electrodes separated by a liquid dielectrics under the application of high voltage stress. Clear? So here you can see there are number of processes which are responsible to enable the formation of this spark. Okay, the pink representation denotes the formation of this spark, and you know that the spark always makes the full spark between two electrodes always makes a short circuit between the two electrodes, where the potential across two electrodes, let us say this is the electrode A and this is the electrode B. So when the potential across this A and B becomes more than the withstanding capacity of this dielectric, the spark is created. Okay, so one is the electronic breakdown mechanism, which we can usually see in the dielectric materials. Second is suspended particle mechanism. Third is the cavitation and bubble mechanism. Fourth is stress oil volume mechanism, breakdown due to the moisture content, and the thermal mechanism. Okay, so except electronic breakdown, if we are considering the commercial liquid, then mostly the presence of impurities are more responsible for the production of this spark or the development of this spark. Okay, so for the commercial liquids, we are basically targeting upon the suspended particle, cavitation and bubble, stress oil volume mechanism, breakdown due to moisture, and the thermal mechanism. So if we are considering the types of liquid, then they are classified into two broad categories depending upon their impurity level. So one is known as the pure liquid, and second is known as impure liquid. Okay, so this is known as a commercial liquid as well. So now we have the two different types. One, that is the pure liquid, which do not contain single impurity in it. So when we are considering a perfectly pure liquid dielectric, electronic breakdown is observed. Okay, as there is no impurity present in the liquid dielectric, suspended particle mechanism is absent, cavitation and bubble mechanism is absent, stress dwelling volume is absent, due to the moisture content is absent. Okay, but when this pure liquid achieves the age successively, you can observe all these processes as well. Okay, so you cannot say that if I am using the pure liquid in the transformer and the breakdown takes place, then it is only the electronic. It depends upon the age of operation of the equipment, which is continuously in subject of the high voltage stress and the state of the condition of insulation. Okay, so based on this, all these processes are always observed when the liquid dielectric is a part of the high voltage device. Okay, so in case of the pure liquid, to achieve the processes from 2 to 6, it will take a longer time. Okay, so generally the cost of the pure liquid dielectric is obviously more as compared to the commercial. So industries always thinking of the cost. Okay, so industries are preferred to use the commercial liquids, and commercial liquids are always contains some percentage of impurity. Okay, so to utilize or to use that commercial liquid as a purpose of the insulation, first we need to purify that oil. We have already discussed the role of the purification system, okay, in a previous lecture. So I am not going in that of the detail. Okay, that how the purification of the oil is done. Once the purification is completed, then how we can determine the quality of the oil. Okay, so today I am not going to focus on that concept. So impure liquid, as it contains the some sort of the impurities in it, so that impurity may be in the form of the solid particles, maybe in the form of the gaseous inclusions or the bubbles, it may be in the form of the moisture content. Okay, any of the impurities you can consider, and it may be associated with the impure liquids. So before applying it to the high voltage equipments, they need to go from, or they need to pass from the purification system. So let us discuss the breakdown mechanisms. What I have written on this board one by one. So let me wipe out this first. So let us touch upon what exactly and how the electronic breakdown takes place. Okay, so let us assume a simple parallel plate capacitor. Okay, here I have shown the parallel plates. Suppose this is plate A and this is plate B. Both the plates or both the electrodes are supposed to separated or filled by this oil. Okay, this pink one represents the oil. The distance of separation is supposed to be. Now here I am giving the high voltage, and suppose the opposite electrode is ground. Now you know the role of the capacitor. When I am giving the voltage, the capacitor will start to charge. Okay, so the process is known as that the capacitor is now start to store the energy in the form of electrostatic field. Okay, in the form of the electrostatic field. Electrostatic field, it means that the electric field, and you know that electric field E is given by V upon D. Now if we recall the ionization processes. Okay, ionization by collision, photoionization, secondary ionization, electron attachment. We need to consider the electron attachment as well with the transformer oil, because that liquid is hydrocarbon in nature. Okay, so there always be the electron loss process. So when we are giving the voltage, this capacitor will start to store the energy. It means that the electric field intensity is developed. So when I am measuring the potential, at each and every point I can able to measure it. Okay. So now how this electronic breakdown takes place? Very simple phenomena to understand it. When we are giving the voltage, okay, the electrons must be injected to assist or to lead the conduction process in the insulation. Now when the conduction takes place, then and then you can have the development of electrostatic field. Okay, so here this electrode is made up of a metallic material, and this metallic material has the work function. The unit of work function is normally in terms of the electron volt. The significance of this work function is to prevent the injection or to dislodge the electron from its surface. Okay, and this will depend upon the magnitude of the applied voltage. So now as we are applying the higher voltage, okay, as we are applying the higher voltage, it will collapse this work function which previously acting as a barrier to prevent the injection of electron. Okay, so now under the application of the high voltage stress, the work function of the metallic electrode gets collapsed. Now once it gets collapsed, the electron is injected from the surface of the electrode. Okay, we have seen that to assist the ionization process, the primary electron is necessary. Now what this electron is doing? The electron gains the kinetic energy from the applied voltage. Okay, now why it gains the kinetic energy? Because the voltage, we also know it as Emf Electromotive Force, the force which is required to move the electron from one point to the other point. Okay, so as the voltage application is continued, this electron will gain the sufficient kinetic energy and accelerated towards the target electrode. B is the target electrode. So now electron is now moving towards the target electrode against the electrostatic field. So now electron has kinetic energy. Okay, so it has a motion. So now during the traveling, see, initially the liquid is electrically neutral, so it contains the equal number of positive charge and equal number of negative charge. So now as the electron is accelerated towards B or towards the target electrode, it will make a collision with the neutral particle. It will make a collision with a neutral particle, this blue circle. The electron will collide with this neutral particle which contains equal number of positive charge and equal number of electron. Okay, so where the positive charge is lies at the inner orbit and the electrons are at the outer orbit. So this primary electron E, which has just injected from the surface of the electrode, which is traced by the high voltage is now accelerated towards the opposite side, and during its traveling it collides with this neutral atom. So let me write it in terms of one chemical representation. So electron will collide with neutral atom. Suppose the neutral atom is A. Okay. Now as this electron is accelerated, it means it has a kinetic energy. Okay. Now as it has a kinetic energy, it will collide with the neutral atom. So when this electron collide with the neutral atom, it will give up its kinetic energy. It will give up its kinetic energy to this neutral atom. As a result, what happens? The molecular structure of this atom gets destroyed. As a result, it will introduce the electron, positive ion and electron. Okay, so to avail this condition, to avail this situation, to avail the dislodge process of the electron from the neutral structure of atom, the kinetic energy of this primary electron should be greater than the ionization potential. Clear? So now into the gap, what we have? We have one more electron and the positive charge. Let us say this orange one indicates a positive charge. So now into the gap we have the two electrons. Again these two electrons gains the kinetic energy, accelerated towards the opposite side. During its acceleration it will collide with the neutral atom and further produces the positive charge and the free electrons. Okay, now suppose this contains the negative charges. Suppose I am giving the negative supply. Okay, so all these positive charges are now accelerated towards the anode, towards the negatively stressed electrode, where they will make the collision and introduces the secondary electrons. So ultimately there are the primary electrons and the secondary electrons as well, and all these electrons are non-uniformly distributed. So like this, you can observe like electron avalanche, and when this electron avalanche meet the opposite electrode, the complete spark is created. Okay, so this phenomena we can observe completely in the pure liquid when it does not contain any impurity layer. Clear? So this is the electronic breakdown, where the breakdown takes place because of these electrons only. Okay, there is no role of impurities, because the impurities are not present. We have considered the pure liquid. Okay, so as there is no impurities, the breakdown which happens is because of the electron avalanche. So that is the electronic breakdown. Now let us discuss the suspended particle mechanism. Now let us consider that the liquid dielectric contains the solid impurities. Okay, solid impurities may be in the form of the fiber materials, okay, or the ionic impurities. So here there is a question that when we are using this liquid dielectrics in the transformers, which is an enclosed structure, then what could be the source of producing these ionic impurities and the dead fibers which can act as a solid dead particles. Okay, dead particles, it means that when it is dead, it means they are force conducting in nature. Okay, because they are acting as an impurity level. So how how we can say that the impurities are getting dissolved? Because when we are purchasing the commercial liquids, first we are purifying it, and after the purification we are conducting the breakdown voltage test just to decide its quality. So once the quality is good, then we can use it in the transformers or the circuit breaker for the purpose of the insulation. So here now we have a question that what are the reasons, what could be the possible reasons which can produce the ionic impurities or the fiber impurities. Okay, so let us consider the very good example using the transformer. Let us take the case of the transformers. Okay, I am simply drawing a transformer in which you found the liquid dielectrics. Okay, then there is a winding. Okay, the tank is grounded. Now here there is a conductor, and here there is the high voltage line. This is the bushing, and this is the tank of the transformer which is grounded. Okay, this is the winding. Now you know that in case of the transformers, not only the liquid insulations are used, but the solid dielectrics and the composite dielectrics are also used. Okay, like the impregnated paper. The impregnated paper is used between the two turns of the same winding. The solid dielectrics are used to isolate the high voltage winding and low voltage winding at the core. Okay, so the different types of materials are used. Okay, then the tank of the transformer is made up of a metallic material. Okay, so considering the materials by which the entire transformer geometry has been developed, you can somewhat get the reasons to achieve the inclusions of these solid particles. Okay, so those solid particles are maybe in the form of the ionic particles. So how the ionic particles may get dissolved or may get included in the transformer coil. So when we are giving the voltage, okay, suppose let us assume that the voltage is not applied and the transformer is placed under the offload condition. I am not giving any supply, even I am not connecting the loads any kind. Okay, you just simply assume that the transformer is placed into the substation over a longer time. Now as you can see, the liquid dielectrics, okay, they are chemically formulated. The solid dielectrics, they are chemically formulated. Impregnated papers, they are also chemically formulated. Okay, that metallic tank also the chemically formulated. So as the transformer is in off condition over a long time of duration, there always be the chemical reactions. Okay, and these chemical reactions are the responsible to produce the oxidation effect to the inner wall of the tank. Okay, and because of that oxidation, because of this oxidation process, the ionic impurities may get dissolved or may get added into the tank of the transformer when these ions or the ionic material detached from the inner wall of transformer. So this is the one of the major reasons to consider the inclusion of the ionic impurities. Ionic, it means that the impurities which are ionic in nature. Okay, so we need to consider the metallic parts. Okay, not only through this inner wall of the transformer tank, but the bolts and everything, whatever we are using in the form of the ionic metals. The another is the fiber impurities. Fiber, okay, So generally we are using the press board as a solid dielectric which is fibric in nature. So because of these chemical reactions and the electrochemical reactions over the long time of the transformers operation under the heavy stresses, they may detach the fibers from the surface of the solid dielectrics. Okay, so as a result, what happens? Those fibric impurities from the solid dielectric surface gets detached and further dispersed into the transformer wire. Okay, if I am rubbing the wood, then you might have observed the some particles are getting detached and they are directed towards the ground side. That is because of the force of the gravity and the weight. Okay, so the same reasons are responsible for the gathering these particles to the ground level or to the ground surface of this metallic tank. Now see how they are distributed. Now as we are applying the voltage under the voltage to the transformers, under the normal operating conditions the insulation will store the charge. Okay, so as a result what happens, the particles are distributed like this. Okay, and successively they are traveling to the ground side. So now when the voltage is applied, now as these all are the dead particles, have the relative permittivity value other than the relative permittivity of the liquid dielectrics. So let us assume that the relative permittivity of the liquid is epsilon 1. Relative permittivity of oil is epsilon 1. Epsilon 2 is the relative permittivity of solid particle. So when I am considering the solid particle, the epsilon 2, I am only assuming the fiber type of material. It means that the particles which are getting detached from the surface of this solid dielectric material, and it has epsilon 2 always greater than epsilon 1. Okay, epsilon 2 greater than epsilon 1. So there is a mismatch of the relative permittivity. The permittivity of the solid suspended particle is of course higher than the permittivity of the liquid dielectrics. So what exactly happens when the high voltage stress is applied? When the high voltage stress is applied, the force is exerted first at the location of the suspended particle, because they are the dead material. Now as they are dead material, now they are representing the conduction phenomena. So the potential gradient which is developed at the site of this solid particle is obviously higher compared to the force that you can see in the pure region of liquid. Okay, so here the field intensity is higher, so high amount of electrostatic force is developed, and what this electrostatic force is trying to do, they are trying to gather the particles which are distributed in the liquid dielectrics. So the force which is exerted between the particles in the direction of either towards the maximum stress or towards the lower stress. Okay, it will depends upon this characteristic, either epsilon 2 is greater than epsilon 1 or epsilon 2 is less than epsilon 1. If you found the presence of the solid particles, then this will be the relation, epsilon 2 is greater than epsilon 1. It means that the force which is exerted is direct the particles towards the maximum stress side. If the impurities are in the form of the gases or the bubbles, which have a low permittivity compared to the liquid dielectric, then they will tend to exert the force in the direction of the lower stress region. Okay, so our point of interest is to discuss about the influence of this solid particle. So I am not going to touch upon this epsilon 2 less than epsilon 1. Okay, so we need to deal with this solid suspended particle, which obviously have the higher permittivity compared to the permittivity of the liquid diameter. So now, when the voltage is applied, the potential gradient across the impurity is increased. So ultimately, where this particle gets charged, under the application of the high voltage, it will try to attract the distributed particles to make them in the same direction to produce the spark. Okay, so to align themselves, to collect themselves in only one direction, what it needs? It needs a force. So the force F is given by 1 upon 2 R cube into epsilon 2 minus epsilon 1 divided by 2 epsilon 1 plus epsilon 2 into grade of E square. So from this equation you can determine the magnitude of the force which is produced to attract or to make the non-uniformly distributed particles into one direction to break the gap between two electrodes. So the magnitude of this force depends upon the radius of the particle if we are considering the spherical one. Okay, so shape and size of the particles, it depends upon the relative permittivity of the particle, it will depend upon relative permittivity of the oil or the liquid and the gradient of E square. It means onto this E value. E is your electric field intensity. E is equal to V upon D. So you can say that it also depends upon the magnitude of applied voltage and the distance of separation. Okay, so considering everything, then we can say that the breakdown due to this suspended particles depends upon the size and shape of the particles, permittivity of the particles, permittivity of the liquid dielectrics, the applied voltage magnitude, type of applied voltage, whether it is AC or the DC. Okay, then it also depends upon the distance of separation between the two conductors as well. Okay. So what happens when the force is seen? When the force is there, let me first rub this. So gradient of E square. So now over here, this particle experiences the maximum stress. This particle experiences the maximum stress. So all these particles are now move towards the maximum stress region from the lower stress region. Okay, if I am starting from this, then the stress is reduced as I am going towards the ground side. Okay, zero potential. So now all this will align in the direction and finally bridge the gap. Okay, so here it will produce the spark. Okay, so the breakdown due to the suspended particles, breakdown due to the suspended particles depends upon the nature. It means the type of the particle, and second the number of particles. If we are considering a single particle only, suppose I am considering this single particle, only one particle is present in the liquid dielectric, then what exactly happens? When I am giving the voltage, the potential gradient at this particle becomes higher. Okay, so we can say that the potential available across this solid particle is more than its former threshold value. So it will causes the local field enhancement, and as there is a local field enhancement, it will partially bridge the gap, and that is known as a partial discharge phenomena. Okay, so once this situation is happening, what happens? It will vaporize the liquid surrounding the particle. The produced spark will heat up the oil, and once the oil gets heated, it will produces the gases. And gases, it means epsilon 2 less than epsilon 1. Okay, so generally the bubbles are created which have lower permittivity compared to the permittivity of the oil. So again they will make a one kind of the stable change after its prolonged operation, and finally produce the complete breakdown. So the breakdown due to this suspended particle depends upon the majorly two factors. Number one is the nature of the particle, and second the numbers of the particle, whether they are single or multiple in nature. Clear? So this is how the breakdown will take place if the liquid dielectric contains the solid particles. Now as they are suspended means that detached, okay, from the surfaces of either the metallic tank or from the solid dielectric surface. Now as they are suspended, okay, this is the process that how the policeman gets suspended, okay, from his service. Similarly, the particles are also suspended from their duty, and once they are suspended, they will emerge in the oil. Okay, but they are now dead particles, so now they are acting as a path for the conduction process. So this is how the breakdown will take place due to the suspended particles. In next lecture we will see the mechanisms by these cavitations or the gaseous pockets, stress oil volume mechanism, breakdown due to moisture, and mechanism. Okay, thank you all.